Have a bit of discussion about our assignment here. Okay, so I'm super excited about this assignment. All right, so I've been working on it for a couple of weeks now, and like you've heard me just conveying, that's the beauty of mathematics. We can build up this whole deductive system that it just has to be true. Okay, because by these definitions that we've set. So this stuff that we're doing, all right, is originally written about what have we got there? 300 BC, so 2,300 years ago. All right, in Ptolemaic Egypt. All right, so Euclid of Alexandria. So Alexandria is that famous city with the lighthouse that was supposed to be like the ancient library of the world and it burnt down. Anyway, so this book is basically, we're still using these principles today. What you're learning is what Euclid wrote about 2,300 years ago. All right, these sort of proofs, this whole system. So pretty amazing that we tend to think of ancient people as perhaps less intelligent than us. They certainly weren't. In many ways, they were more intelligent than us. All right, they just perhaps had access to less technology, and most of them had to work the land. All right, so look at this. 500 years ago, 90% of people worked in agriculture. So that means they were working on providing food for the whole population. Do you have any idea how many people work in agriculture now? 2%. 2%. Isn't that incredible? All right. So all of a sudden, you've gone from 90% of people, you've freed up 88% of the population, and so then they can do stuff like innovate and make technology. And that's why we've seen this massive explosion of technology in the past sort of 500 years. All right. So where are we up to? Part A. So there's three parts to it. All right. Part A we've sort of explained already. We're talking about the difference between deductive and inductive reasoning, and I haven't told you explicitly what a theorem is, although we've been applying theorems, so you'll be able to look that up and see the link between deduction, our definitions, our axioms, and then a theorem. And then even there, a proof by contradiction, which is another proof method that we did perform when we were talking about the radius tangent theorem as well. So all we're doing there is you're just having a brief discussion about these ideas, because that's what we're going to unpack in the assignment. So that's part one. Okay, in part two, you're going to define a full revolution, a half revolution, and a quarter revolution. So this is going back to one of our first lessons. We said a full revolution is 360 degrees, half revolution 180, and a quarter 90. All right, that's just by definition. So this is sort of what you're going to be doing. And then, using that, you have to prove these following three things. That vertically opposite angles are equal, that angles in a triangle add to 180 degrees, and that the external angle of a triangle is the sum of two interior angles. So when I say prove it, I mean formal proof with the diagrams alongside and with some accompanying text that tells you or informs the reader on what you're performing here and how you're doing it. So, like if we're just talking about intersecting lines, I can draw two intersecting lines. I'm going to label it, A, B, C, D, and we can call that X. All right, and then you can do stuff like, okay, well, let's let angle AXD equal alpha. And then you can go, therefore, angle DXD is 180, take alpha. All right, and provide your justification because angles on a line add to 180 degrees. And then therefore, so if this is 180, take alpha. Well, this is a straight line as well. So BXC is going to be 180 take 180 take alpha, which is alpha. And so this is alpha, this is alpha. You've proved that vertically opposite angles are equal, regardless of the size of the angle. So you're going to perform those three proofs. All right? And so this is deduction, isn't it? We started with these definitions, and then we haven't done any inductive process whatsoever. We've just said, this is true, this is true, this is true, therefore this is true. And what's the link? Therefore, vertically opposite angles are equal. Okay, so that's a deductive process. Then we're going to perform an inductive process. So let's move on to part three. So I only did the first proof for you there, vertically opposite angles are equal. You'll need to do the other two. We have done them in class together. Okay, part three. Develop one of the following as an axiom using three inductive pieces of evidence. All right, so this is the example. This is three inductive pieces of evidence. All right, evidence one, corresponding angles are equal. Evidence 2, corresponding angles are equal. Evidence 3, corresponding angles are equal. Therefore, our axiom, something that we're going to assume to be true, something that we're going to hypothesize, that we're going to conjecture, based on this inductive evidence, is that corresponding angles are equal. So if corresponding angles are equal, all right, if that's our axiom, then we can go, all right, well, remember how we said vertically opposite angles are equal? Well, that means this angle here is also alpha, because they're vertically opposite. And then you've proved that alternate angles are equal. All right? And angles on a line are 180, so this is 180, take alpha. And so then you've got co-interior angles add to 180. So you've proved those other two theorems based on that inductive argument that we've made. Okay. Yeah, and so that's what it says. So develop one of the following as an axiom. So up there, I've used corresponding angles. I've said you need to use either alternate angles are equal or co-interior angles are supplementary as your axiom. Okay, because up there I've demonstrated how you're going to use corresponding angles are equal. All right, and then use your axiom to prove all other properties. So there's only two other properties, well there's only three all up. So there's corresponding angles are equal, there's alternate angles are equal, and co-interior angles are supplementary. That means they add to 180 degrees. Okay, then part C. Perform at least one of the following investigations. I've got 3 there, and you get to choose which one you're going to do. I think they're all quite similar in difficulty. So you can have a look, have a read through. Basically, there's 3 investigations there that you're going to perform, and then leading up to a proof. I'm not going to go over them so much now. It's very scaffolded, follow the steps. And with these ones, let me stress with these ones, I'm going to answer your questions, but I want to see you make an attempt at it. All right, so I don't want you to say, I need help doing this. I want to see you try something, and then you can say, I'm a bit stuck, what's this next part? All right, but I just want to see you putting a bit of effort in, but yes, I will help you if you are stuck. So yeah, have a read through of investigation 1, investigation 2, investigation 3, see which one you might want to do, because that's sort of the crux of the assignment. This stuff here is very straightforward. Everyone's going to have pretty much the same. All right, you might have different letters, rather than A, X, B, C, D, you could have something different. Might have different angles, different shapes. So that's enough from me. Let's get into it. Oh, sorry, one more thing. Just about the report. Okay, so that very last thing. Maximum of 8 pages. Okay, so that is 8 single-sided pages. So if you have a double-sided page, so that'd be 4 double-sided pages. All right, and that's the assignment. But that does not include your appendix. Okay, so anything you put in your appendix does not count towards your page limit. And then there's just what you need to include in your report. So brief outline. So you've got your introduction, method, what you're doing here, application. So when we submit our draft, I can give you a bit more feedback around the structure of a report. So that's Thursday, week 11, when we submit our draft. But for now, let's get into it, see how we go.